All of the images in this movie come from a book called Database Modeling from 0 to 60 in 4 Seconds, owned by Gavin Powell, and I am giving permission to VTC to use these images. There are two main types of databases in use in modern database environments that it's important to understand the very basic differences between an OLTP database, or an online transaction processing database, versus a DW or data warehouse database. An OLTP database being online transaction, its meaning is generally obvious. What it means is that it services online transactions. So when you go and make payments and do single small transactions or functions, things with your bank account or something like eBay or Amazon, you're not actually listing information on the screen, you're actually doing an activity that involves changing information. That's an OLTP database. A data warehouse is where you go and you run large reports, and it reads from a slightly different structured database that is tuned or geared towards reading information and spitting out large amounts of information all at the same time, or aggregating into small amounts from large amounts. This database here is an OLTP database. It's very much divided up and broken down into its individual objects. It's, in relational database parlance, known as normalized, where you have lots of one-to-many relationships and everything is linked together in a large diagrammatic structure, if you like, or an interlinked relational structure. In other words, a band has many musicians, a musician has many advertisements, a band has many shows, and a venue has many shows as well. If you can see the interlinked relationships, these are actually called associative entities, where there is actually a many-to-many relationship between venue and band, and musician and band. Those many-to-many or associative relationships are resolved by the advertisement for musician and band and the show for venue and band respectively. This is a slightly different model to the one that we looked at in previous movies in this chapter that just looked at musicians and shows. This one looks at musicians, shows, bands, etc. A little bit more discography, all the CDs they produced, the merchandise they're selling, the instruments they're playing, and so on and so forth. This particular model is a data warehouse form of a section of the OLTP model. It basically looks at just the artists and joins all the information. Well, actually it's not a section, because if you look in here, for artists you have instruments, genres, merchandise, musician names, band names, discography, shows, venues, and so on and so forth. Go back to here, you can see that discography, merchandise, venue, genre, instrument. What I've actually done is I've left some of them white and some of them blue. The white ones are static information that doesn't change very much. The blue ones are dynamic information that changes often. And what you'll find is that the static information will be placed around a central object table called a fact table in the warehouse. What you're trying to do in a warehouse is you're trying to reduce the number of joins. So when you run a query, you run artist and you join to genre and instrument merchandise. It's a single join. This is a very large table. It's much more efficient to do that than it would be to run a report on all of these tables and join all of these tables together in a single query. In other words, musician, band, advertisement, discography, merchandise, venue, show, genre, instrument. It's very complicated to join tables together, and it's very slow. So when reading large amounts of information, this is a much more efficient model. We could actually take the data warehouse and break it down a little bit more and pull some more static information out, kind of. But then if you want to read, for instance, your reports only join the fact with the discography, then you're joining one table to one table. You've got a two-table join, that's sufficient. If you're running reports that's reading all the data at the same time, then the other model is better. In other words, this model. Now, let's look at something else briefly. If we go back to this initial model, and now we're going to scan forward through a couple of models that we have. Here's another slightly more detailed version of the OLTP model. This model, however, includes all the data types. This is known as a physical model, and this is known as a logical model. The logical model really gives you a graphical picture in the simplest form. It's a lot more complicated than that. And the physical model includes things like data types. You can actually also have changes in the physical model that override even the tables and the relationships from the logical model. Also, looking at the warehouse again, here's a very detailed broken down warehouse. This is the logical model. Also looking at the data warehouse, here is the logical model for the warehouse with a very broken down form of the warehouse. And here is the physical model, which again has just the data types.